let's see if we can attempt another question. I want to pay attention because I think this one is a bit tricky than the other ones we have solved thus far. Okay, now let's go. Okay, solve the equations 3x plus 5y is equal to 47 and 2x plus 3y is equal to 29. That's 3x plus 5y is equal to 47 and 2x plus 3y is equal to 29. Okay. Now, I want you to pay close attention to the two linear equations that we have been given. In the first equation above, we have 3x plus 5y is equal to 47. Note that the coefficient, I want you to note the coefficient of the unknown letters. The first coefficient of the letter x in the first equation there is 3. The coefficient of the letter y in the first equation there is 5. And let's go to the second one. We have 2x plus 3y. Now, for the second equation, we have 2 as the coefficient for x in the second equation, and then we have 3 as the coefficient for y in the second equation. Now, that is equal to what? It's equal to 29. Okay. Now, under the elimination method that we are actually using now to solve these examples, we have to be careful because we are not having like numbers. In the previous examples I've solved thus far, you will note that the examples I've solved thus far, you will note that I'm always having like numbers. But in this particular question, we don't have such. For the first linear equation, we have 3x, we have 5y. In the second linear equation, we have 2x, we have 3y. These numbers are not like numbers. So for x now, we have 3 as the coefficient of x in the first linear equation. We have 2 as the coefficient of x in the second linear equation. So if we want to eliminate, we have to think very well. Then for y, we have plus 5 as the coefficient of y in the first linear equation, and then we have plus 3 as the coefficient of y in the second linear equation. So if we want to eliminate, we have to think wisely. So we have to settle down and think properly. Which particular letter are we going to eliminate? If we are going to eliminate x, then we have to make sure that our 3x, the 3x that is the first linear equation, and the 2x, we need to make sure we introduce numbers that will make those two coefficients to be the same. Because if we say 3x minus 2x, we've not eliminated x. We're going to have x. So we need to actually introduce something that will unify them and make them to be like numbers. So the only way we can do that in order for us to eliminate x is to introduce numbers that can actually relate them together. So if you check, for the first linear equation, we have 3x. In the second linear equation, we have 2x. So we have to introduce 2. Use 2 to multiply the first linear equation and use 3 to multiply the second linear equation. If you do that, you're going to get the same coefficient for your x in the first linear equation and the second linear equation that you're solving in these simultaneous equations. Yes, but if you're going to do that, it has to be thorough, such that the number you are using to multiply a particular linear equation must multiply every expression, every item, every value that you have there. So in this wise, now how are we going to solve this now? We are introducing 2. So 2 is going to multiply your 3x. 2 is going to multiply your 5y. 2 is going to multiply your 47. That is for equation 1. Then you now introduce 3. Now you're introducing 3 for the second linear equation because you want to make that 2x to turn to something that will be the same as the coefficient of the of the number that is going to appear as x above. So we use 2 to multiply up because 2x is down. And we're using 3 to multiply down because 3x is up. So if we use 3 to multiply down, our x down will change to 6. If we use 2 to multiply up, our x up will change to 6. But we have to do it thoroughly. It has to go through. And the same thing with the second one, it has to go through. If we do that, we're now going to have a situation whereby we have like numbers for what? For the first linear equation and the second linear equation for x as coefficients, as like numbers as coefficients. So let's proceed. So now we have what? 3x plus 5y is equal to 47. That's our first linear equation. It will change. We're now going to change that equation to a third equation. Now, how are we going to do that? We multiply by 2. 2 times 3x is 6x. Write it down. 2 times your 5y is 10y. That is 6x plus 10y. Now, 2 times 47 is 94. So now, you now have your 6x plus 10y is equal to 94 as your third equation. Don't forget, your first equation has now transformed to a third equation. Good. Now let's go to the second equation. The second equation, before we were having 2x plus 3y is equal to 29. Now we're multiplying all through by what? By 3. 3 times 2x is 6x. Write it down. This line of equation is going to be our fourth equation. Now, multiply your 3 by 3. If you multiply 3 by plus 3y, it's now going to be what? 9y. Write it down. Then multiply your 3 by what? By 29. Yes. If you use your 3 to multiply out 29, you will now get 87. So now our fourth equation will now be 6x plus 9y is equal to 87. Aha! We have transformed our two initial equations to two different equations now. Equation 1 is now equation 3, and equation 3 is now equation 2 is now equation 4. So we'll now use equation 3 and equation 4 to what? We're now going to introduce our elimination method with equation 3 and equation 4 because it can now what? A particular unknown letter can now be what? Eliminated. Please remember, we had to go through this procedure because we could not find like numbers that we can actually use to eliminate a particular unknown. Note that is the reason why we went through this long procedure.